Hello everyone, welcome to the channel. Today's topic is AI tools and frameworks. Why we need AI tools and frameworks. Both technical and non-technical professionals can build AI systems without deep coding expertise. We need AI frameworks to build, train, deploy, and scale AI models. Frameworks provide high-level abstractions of complex algorithms, APIs, interoperability with datasets, cloud platforms. Frameworks not only help developers but also non-technical people without software coding experience to build AI workflows like AI agents, AI agentic systems. Frameworks also provide community support. Coming to tools. Tools help in analyzing and visualizing the AI model flow. Tools also help in tracing and debugging the AI workflows to fix the issues. The most popular framework and tools are Tensorflow, Pytorch, LangFlow. Applications like AI chatbots, AI agents are built using these frameworks. TensorFlow, developed by Google, is used for deep learning and building AI models. TensorFlow designed to perform fast computations. TensorFlow is based on static graph. TensorFlow is suitable for production environments. For Edge AI, TensorFlow Lite version is used on mobile phones. TensorFlow used in voice assistant applications, language translator applications, and image classification applications. The next framework, Pytorch, developed by Fair team at Meta. Pytorch is used in research and prototyping. It is also used in production using tools like TorchScript. PyTorch framework used in machine learning algorithms, reinforcement learning. Remember the machine learning algorithms, supervised, unsupervised, and reinforcement learning? So the PyTorch framework is used in reinforcement learning. In reinforcement learning, agent learns and make decisions through trial and error in feedback loop with rewards and penalty. Imagine a self-driving car simulation. At each point in time, we can decide what to do next, whether to accelerate or whether to apply brakes or take left turn or right turn. We make movements based on the situation on the road and on the environment. TensorFlow is used in production environment and PyTorch is generally used for research. Then we have LangFlow, LangChain, and LangGraph. These are Python frameworks designed to build applications powered by large language models like LLMs. LLM providers are Amazon Bedrock and OpenAI, and there are many other LLM providers. LangChain, LangGraph, and LangFlow used in agentic AI systems for combining AI models with external APIs, tools, and databases. The question is how to choose the right framework and the tools. For this, let us look into AI framework flow. We have data and machine learning algorithms as the core starting point. On top of the data, we have AI frameworks like TensorFlow, PyTorch, and LangChain. Developer can decide the framework based on the application they want to develop. If developer want to develop a voice assistant application or an application for mobile devices, then developer can choose TensorFlow or TensorFlow Lite. If developer wants to develop robotic applications like self-driving car, which is based on reinforcement learning, then developer can choose PyTorch. If developer wants to develop tools to generate software code automatically or developer wants to develop an AI agent that Then developer might choose LangChain, LangGraph or LangFlow with OpenAI models or Grok. Application developers, either technical or non-technical person, just call the frameworks and APIs to build applications without bothering about the internals of AI systems. Now let us understand LangChain, LangGraph and LangFlow. LangFlow built AI agents quickly with visual interfaces without coding experience. It's all about drag and drop in LangFlow to build the AI agents. LangChain allows users to easily compose chains, that is, sequence of components to perform complex tasks. LangChain interacts with LLMs. They provide tools to create prompt template to facilitate interactions. LangChain introduced LangGraph to build multi-agent applications. LangChain also includes LangSmith, a developer platform for testing, debugging, and monitoring LLMs. LangGraph is an open source framework. LangGraph is part of LangChain ecosystem, and LangGraph is used for advanced AI workflows. As the name suggests, LangGraph is based on graph-based thinking. Graphs have nodes and edges. Graph nodes are actions, edges are paths between the nodes. This requires some coding skills. LangGraph gives full control to developers to change code and then trace how agent behaves. Moving on to the next slide, LangFlow framework. LangFlow framework is a low-code visual solution that is simple drag-and-drop solution for building AI agents. You can install these tools and frameworks on your laptop, or you can access these tools via cloud. So the first step is install the tools. There are multiple tools and multiple approaches to build AI agents. We will look into some common steps that are followed by open source frameworks to build AI agents. So the common step for building the AI agents is first install the tools on your laptop or get access to the tools which are present on the cloud. Select the LLM model from the model component. Then assign a role to the model by prompts. Let's say role like data analyst if you are preparing an AI agent to analyze your company sales data and output the sales summary report. Then the prompt could be something like act as a data analyst for the sales department. This chat prompt is input to LLM models. As we are building AI agents, after LLM model component, select agent component and then configure the components. Agent components will have description about the tools, guides the agent in decision making process on how and when to invoke a tool. Then comes memory component. This is required when you want AI agent to maintain the history of the prompts or when you have follow-up questions. Like after getting the sales summary report from the previous example, you may ask AI agent to list the top 5 products from the sales summary report. So the prompt history need to be stored and retrieved by the AI agents. The memory storage can be internal or memory storage can be external. If you have multiple agents, then choose the options like custom components and customize the components as per your requirement. Then analyze the logs, tracing agent actions and reasoning. Get the components logs at each step like log set model components, LLMs, get log set agent component, get log set memory component, and check if the results at each component level are as per the expectations. Component-wise logs of the entire flow helps in fixing the agent actions. If the logs are fine as per the expectations, then deploy the agent. Once deployed, LangFlow exposes REST APIs that can be integrated into the application. And for agent-to-agent communication, you can use MCP protocol or agent protocol. Let us look into LangChain. LangChain allows users to easily compose chains, that is, sequence of components to perform complex tasks. Chains interact with LLMs, provide prompt templates to facilitate interactions. Prompt template shapes how queries are presented to the language models. LangChain embedding class interfaces with various text embeddings like OpenAI or Hugging Face. Chains interact various components into sequence. Chains integrate various components into sequence, allowing for a streamlined workflow. This might include connecting LLMs with prompt templates, connecting with memory, and then output parsers. Callback systems allows developers to monitor and log interactions at different stages of applications. LangChain is suitable for applications like voice assistants or advanced AI chatbots. The next component is LangGraph components. Connect Python functions together in LangGraph because it is based heavily on coding. Connect Python functions. As we know, graph has nodes and edges. Similarly, LangGraph has nodes and edges. Nodes perform actions like calling an API, invoking a tool, or answering a question. Edges connect two nodes and decide the next step. When there are multiple possible next steps, what to do? When there are multiple possible steps, use conditional logic. Instead of simple logic, use a conditional logic like if and else to decide which path to follow. Nodes are like bus stops and agents, and edges are paths connecting those bus stops or bus stations. Imagine a software project with project managers and developers. A project manager is a node sending messages like project goals and tasks and assigning tasks to team members. This is known as message passing because project manager node is passing messages to team members nodes on what to do on the assigned tasks. Other are team members, and team members become active by listening or taking notes during project kickoff meeting. Or team members become active by executing the assigned tasks. Another example, classroom. A teacher is a node, students are another set of nodes. Teacher delivers lectures is message passing. Student nodes are active during lecture by taking notes. The student nodes are inactive when there is no class. A node becomes active when there is a message from the paths known as channels. Nodes are triggered based on edges which define transition from between nodes. Then comes the state. State in LangGraph stores everything the AI agent needs like agent movement from one node to another node. A manager assigns work to the team and remembers what each team member is working on. So the state in LangGraph does the same thing, remembers each point in the agent flow. Creating agents using LangGraph. If you are using LangGraph, then the first step is install the tools and the frameworks for LangGraph. Define the state that could be chat messages. Create LangGraph node that is list of chat messages. And then send those messages to LLMs and then append AI's response. Pass the AI response to the next node in the graph. Finally, compile and run the code. Now let us look into the sample code of frameworks. Here we have TensorFlow, Pytorch, LangChain and LangGraph. We don't have LangFlow here because that is completely based on visuals. If you are using TensorFlow framework, in the source code first include the line import TensorFlow TF, and then based on the application decide the machine learning algorithm that you want to use and call that algorithm. Let's say if it's a supervised learning linear regression, and then if it is classification, then call classification algorithm, then use activation functions and optimize, and then compile the code and you get the output. If you have decided to use Pytorch, then first step is import Pytorch application framework, then choose the model as we discussed in the previous slides. If it is a machine learning reinforcement learning algorithm, then call that algorithm. Then if your application is self-driving cars, then choose PyTorch. Then call the AI algorithm activation functions like ReLU or Sigmoid, and then optimizations, and then compile the code and you have the output. If you want to build AI agents or agentic AI systems, multiple agents, then use LangChain and LangGraph. LangChain, the first line and the code is from LangChain LLMs. From LangChain LLMs, then prompt templates. Then you have LLM model like OpenAI. Then call LLM chain passing the prompt template as an argument. Then you have LLM chain run to run the code and execute it. If you are expert in Python coding, then you can use LangGraph. LangGraph first line and the code is from LangGraph, then define the state of the agent, then as it is a graph based framework, add nodes and edges, and then if you have multiple nodes and multiple edges, then call them as sub nodes and sub edges and then compile the code. So this brings us to the end of this video of AI tools and frameworks. I hope you like this video. Please subscribe to the channel. Thank you for watching.